All right, let's have a look at adding and subtracting surds. So in order to add and subtract surds, you also need to be able to simplify surds. So have a look at my previous video on that if you haven't already done so. All right, the only way you can add and subtract surds, so in this first example, we have 3 surds and we're asked to add and subtract them together. The only way you can do that is if the terms underneath each surd are the same, and here they are not. When the surds are not the same, one of the strategies that we're going to look at today is to simplify each of those surds together. Okay, so let's simplify each of those surds, and then hopefully the number or the term underneath each surd will be the same. Let's see how we go. All right, we're going to simplify each of these. Now to simplify, remember, we break up each of our individual terms in each square root. So the square root of 8 times the square root of a cubed. Let's do that. So square root of 8, times the square root of a cubed. We'll add that to the square root of 72 times the square root of a cubed. And we'll subtract that from the square root of 98 times the square root of a cubed. So all I have done there so far is split up each of my terms into their own square roots. Now I can go ahead and simplify each one on their own. So the square root of 8, we need to split up that number into 2 factors, one of which is a perfect square. And I'm thinking of 4 and 2 because 4 is a perfect square. Let's go ahead and rewrite that as root 4 times root 2, then times, all right, root a cubed. I have a separate video explaining how to deal with these with square roots and powers. But here's the trick. If you have an odd number, you take away 1 from this number, so you end up at 2. Then you halve it. That makes 1. So you take that number 1 and you do this. You write a, whatever the letter is, then you put a 1 there, and then all you do is put a square root of a as an extra on the side. Okay, so it becomes a to the power of 1 multiplied by the square root of a. We'll have another couple of examples coming up very shortly. Let's do that. So adding root 72. Now the 2 factors that I can think of for root 72 are going to be 36 and 2, because 36 is the highest perfect square we can use. Let's go ahead and do that. So root 36 times root 2, and we're going to multiply that by root a cubed, but we can simplify that again. Let's do the explanation again. So whenever you have a square root and a power, if that power is odd, this is what you do. So you take away 1, you'll end up at 2, and then you halve that 2, you'll end up at 1. So you write whatever the letter is, in this case it's a. Let's just do that again. A to the power of 1, that's what number you ended up at. Then you do another square root of that letter. That's the little shortcut. Okay, let's keep going. Subtract. Now root 98, we can split that up into 2 factors, one of which is a perfect square. The highest one that I can think of is going to be 49 and 2. So root 49 times root 2 times, now again we have another root a cubed, that's going to be a root a. Alright, we can simplify this further by evaluating or solving the square roots. So the square root of 4 is going to be 2 times root 2 times a root a plus 6, so that was the square root of 36, times root 2 times a root a minus root 49. We can solve root 49. That's going to be 7 times root 2 times a root a. Alright, there's a lot to look at here, but essentially what we've done is we've simplified each of our 3 terms, but they're all out individually. Alright, we've got a whole heap of multiplications and additions, now, and subtractions as well. Now remember, using our BEDMAS, our hierarchy of operations, we want to multiply our terms first before we add our terms. So it's going to be 2 times root 2 times a root a. Alright, and the way we do that is by multiplying our 2 and our a, because these are the terms outside the square root, and our root 2 and our root a, because they are inside the square root. So let's go ahead and do that. We're going to end up with 2a root 2a. Notice how I multiplied my 2 and my a. The answer is here. And my 2 and my a underneath the square roots are also together in the same square root. Let's try that for the next one. Now we've got 6 times root 2 times a root a. Again, we multiply the terms that are outside the square root, so 6 and a, and then multiply the terms that are inside the square root, so 2 and a. So we're going to end up with 6a root 2a. Last one, subtract. The answer is going to be 7a root 2a. 7a root 2a. Okay, now our factors, our roots are exactly the same. They are root 2a everywhere. So now all we need to do is just add or subtract the terms outside. So we have 2a plus 6a minus 7a. Let's do that. So 2a plus 6a is 8a, and 8a minus 7a is just a. So our answer is going to be a root 2a. Okay, let's have a look at our second example. What I'll do is I'll just quickly resize this working out so we have a bit more room to work with. So we'll just shove that there. All right, now we have some room. Let's go ahead and have a go at our second question. So again, the terms underneath our square root signs are not the same, so we cannot add the numbers outside. We cannot do that. So first step is to simplify each of our surds, each of our square roots. Let's go ahead and do that. So square root of 4 times the square root of a squared times the square root of b, add 5 times the square root of a squared times the square root of b, subtract 3 times the square root of 9 times the square root of a squared times the square root of b. So every term has their own square root sign. Now we can simplify them individually. Let's go ahead and do that. So the square root of 4 is 2. Now we have a square root sign and a squared sign. Now the shortest trick in the book for this one is that whenever you are squaring a number or a term and then you square root it, those two functions do the exact opposite. It's kind of like multiplying a number by 6 and then dividing a number by 6. It's kind of, they cancel each other out. The other explanation which I have used previously is this. Whenever you have an even number, all you need to do is halve that number. So that number becomes 1, and so you end up with a to the power of 1, which is just a. So it's going to be 2 times a times root b. We cannot simplify root b, so it's going to stay like that. Plus 5, now root a squared is going to be a again, times root b, minus 3 times, now root 9 is also going to be 3, times, now root a squared is going to be a, and times root b. So it looks like everything has been simplified as much as possible. And it also looks like, actually, I can see here that this can be simplified further to 9. But essentially, the terms underneath our square roots are the same. So we're looking pretty good here. We might be able to start simplifying and adding and subtracting our surds. So let's go ahead and rewrite this one more time. Let's simplify it a little bit. Now remember, by convention, numbers and letters can be combined together if they are being multiplied. So I'm going to write here, instead of 2 times a times root b, I'm going to write 2a root b. Then I'm going to add that to 5a root b. And then I'm going to subtract 9a root b. That looks much easier now. All we need to do is recognize that our roots are the same. We can now add and subtract the terms on the outside. So I've got 2a plus 5a, that is 7a, and then I need to subtract 9a. That's going to give me negative 2a root b.